The next component in the system is the optional SR1 spring brake valve. It's most often used on longer wheelbase vehicles, but can be used on tractors and straight trucks. Its primary function is to maintain modulated rear axle braking if primary reservoir air pressure is lost. Modulation takes place through the service foot brake, taking advantage of a driver's natural reactions in an emergency. In a rear axle brake system failure, the SR1 modulates the pressure delivered to the rear axle spring brakes in direct proportion to the amount of pressure delivered to the front axle brakes. The SR1 has 4 ports: the number 1 reservoir port connected to the rear axle reservoir, the control port connected to the front axle delivery circuit of the dual foot valve, a supply port to the delivery of the PP1, and a delivery port to the control of the R14 relay valve supplying air to the spring brake cavities. Inside, the SR1 contains 2 pistons. We'll call them piston A and B. Below each piston is an inlet exhaust valve, and above are the springs. The final component is a single check valve. As soon as air pressure starts to build in the rear axle service reservoir, it is also present at the underside of piston A, which is held all the way down with spring force. Its exhaust is sealed, and its inlet is open. As air pressure in the primary reservoir reaches 55 psi, enough pressure is also under piston A to move it up against the spring force. When the piston moves up, the inlet valve seats itself. Continued movement upward unseats the exhaust. As the system continues to charge up to 120 psi, the driver may elect to release the spring brakes. Pushing in the PP1 control valve delivers air from the PP1 to the supply port of the SR1. Piston B, held down by spring force, seals off the exhaust and holds the inlet open. Air pressure from the PP1 enters the supply port, flows past the open inlet valve under piston B, and on to the spring brakes. When the air pressure going to the spring brakes beneath piston B is about 95 psi, piston B rises slightly, closing the inlet, but not enough to open the exhaust. A balanced state is achieved. Both the exhaust and the inlet are closed. The spring brakes are released. The vehicle can be moved. A normal service brake application at this point has no effect on the SR1. Air flows to the front axle service brakes and to the control port of the SR1. It stops there because the inlet valve under piston A is closed. The rear axle brakes also apply normally using air pressure from the foot valve. The SR1 will not be affected by a front axle service brake failure. It monitors only rear axle service brake reservoir pressure. The spring brake will remain released because of the double check valve. The rear axle service reservoir will continue to supply air to the PP1, and the PP1 will continue to supply the SR1. If rear axle air pressure is lost, the driver will be warned, and the shuttle in the double check valve will move to allow the front axle reservoir to supply the R14 relay valve and the PP1. Even though air pressure for the spring brakes is shown in orange, the red front axle service reservoir is supplying the air pressure. However, as pressure drops in the rear axle reservoir, air pressure at the number 1 reservoir port of the SR1 drops, causing piston A to move down due to spring force, sealing the open exhaust passage, and with continued movement to unseat the inlet valve. When the driver receives a low-pressure warning and applies the brakes, only the front axle service pressure will be available. The front axle brakes apply normally, and the same air pressure is delivered to the control port of the SR1. The front axle application air will enter the control port, flow by the open inlet valve, and through the internal passage to the outer surface of piston B. The pressure there will cause piston B to rise, opening the exhaust valve. Air pressure in the spring brakes will be exhausted until the springs are allowed to achieve a balance, reducing the pressure under the inner diameter of piston B. As a specific example, if a 20 psi pressure application is made to the front axle brakes, 20 psi is delivered to the control port of the SR1. It represents a 20 psi control pressure and exhausts enough pressure from the spring brakes to simulate mechanically a 20 psi air application to the service side of the spring brakes. When the foot brake is released, the air pressure in the outer area of piston B is exhausted back through the foot valve. The springs above piston B move it down, opening the inlet, allowing air from the front service reservoir to flow through the double check valve, the PP1, the open inlet of the SR1, and into the spring brakes to recharge them. The spring brakes can be applied and released or modulated on and off about 5 times. Here's a service tip. The number of brake applications depends primarily on the severity of brake application, reservoir size, and degree of reservoir contamination. One reason to drain reservoirs regularly is that the volume of contamination reduces the volume of air available. The SR1's internal check valve assists the exhaust action from the spring brake. Piston B is in the balanced position when the spring brakes are released. The inlet exhaust valve beneath piston B is closed. The check valve is closed because of the spring force and the fact that the pressure beneath the check valve is slightly greater than the pressure above it. When the PP1 park control is put in the park position, air from beneath the inlet valve returns to the open exhaust of the PP1. The pressure above the check valve becomes greater than that below it. The check valve opens. This allows the spring brake hold-off pressure to also flow back to the open exhaust of the dash control. Pressure beneath piston B is then reduced. The springs above piston B can move the piston down, opening the inlet valve. This enlarges the path for air to return to the PP1 exhaust. When the air is completely exhausted, the vehicle parking brakes are fully applied. That concludes our presentation of the parking and emergency brake system. Let's review the devices briefly. The DC-4 double check valve directs airflow to the PP1 from either of 2 reservoirs, whichever has the higher pressure. The manually operated push-pull PP1 moves from the applied to the exhaust position automatically when supply pressure reaches a designated minimum. Spring brakes and chambers convert air pressure energy to mechanical force to apply the brakes. Relay valves speed up the application and releases of brakes, particularly the rear axle brakes. In dual brake systems, the SR1 spring brake valve supplies a limited hold-off pressure to the spring brakes and causes a mechanical application of the rear brakes if there is a loss of rear axle service pressure. The first 3 parts of this series have covered a complete air brake system used on a typical straight truck or bus. Part 4 will present the additional components unique to an air brake tractor and the components necessary in a trailer system. We hope we have increased your understanding of the parking and emergency brake system and its components. For more information and a complete Bendix service manual, contact your local authorized Bendix parts outlet.